Hi, I'm going to solve quiz 3 from week 7 of physics 2 and says like so. The wave function of a wave on a taut spring, it's y equal to, I'm gonna write it here, y, x and t, it's equal to 0.35 meters sine function of 10p times t minus 3p times x plus pi over 4. This is our function, where x is in meters and t is in seconds, okay? So here we have to find what is the average rate at which energy is transmitted along the string if the linear mass density, I'm gonna write it here, the linear mass density, it's equal to 75 grams over meter. And the second question is, what is the energy contained in each cycle of wave, okay? Now we know these facts. We have to use our equation of the amplitude times the sine function of k xwt plus phi. And this is approximately the same as this one, but here we have the values, okay? Once we have this equation, we have to get knowledge of this trigonometrical property that the sine of x, it will be equal to sine of pi minus x. This is the same. So here we can express it also as the amplitude times the sine function of pi minus, and now we can write the constant times dx minus the angular frequency plus phi, okay? And now we know this equation. We can subtract from this one that it's given the values of the things we know. First, we know that the angular frequency, it's equal to 10 pi radians over second. It's this one. Then we also know that the constant kappa, it's equal to 3 pi radians over meter, that it's given here. We also know that the amplitude, it's equal to 0.35 meters because it's given here. And we will also need the velocity. By the velocity, we can calculate by lambda times the frequency. And this is, at the same time, it's equal to the angular frequency times the constant, okay? And we know that this one is 10, and we know that this one, it's 3 pi, okay? So by solving this one, we will obtain 3.3033, and it goes like that, okay? Meters over second, because it's our velocity. Now we have all the variables we can use, so we are asked to obtain the power, okay? That it's the average. The power, we know that for a string wave, we have to use this equation. Well, no, this is the velocity, sorry. Well, now, by using this equation, we know all the details. So we only can substitute, have the density is given here, So times 75 times. Here, what I do, it's at -3, pretend -3 here, because I will put it in kilograms over meters, and it is given in grams over meter. So that's why I write it like this. Then I'm going to use the frequency, angular frequency, that is 10 pi square times 0.35, that is our amplitude square, and times the velocity. And we know that the velocity is 3.333 and goes like that. Okay? By solving this one, we will obtain that the average of the power will be 15.1 watts. Okay? And this is the part A that we are asked the power. For part B, I'm going to write it here. For part B, we are asked to obtain the energy in a cycle. So we know that the power, it's equal to the energy over the time. Energy over the time. And we know that for obtaining the energy, we will have energy equal to the power times. Okay? For obtaining the time will be equal to the period, because it's in one cycle. So for obtaining the period, I'm gonna write it here. We know first that the angular frequency is equal to 2 pi over the period. And for obtaining the period, we will know that the period is equal to this over this. And we know that the angular frequency is equal to 10 pi. So we will obtain that the period is 1/5 second. Okay? So now we know this and we know this. So if we substitute here our values, we will obtain that our power, that is 15.1 watts, times our time, that is 1/5 seconds, we will obtain that our energy is equal to 3.02 joules. And this is per cycle because it's one period. And this is how you solve this quiz.